Thank you very much. I give colleagues a moment or two just to arrive, and then we will make a start in a moment or so. Right, we will make a start, colleagues. Thank you very much indeed for attending this session on whole life carbon. And I want to say thank you in particular to NIHE and to Amy Lewis for organizing it and getting us all, certainly us here at the top table, as we would be in old-fashioned speak, getting us sorted, even telling us when we could have a comfort break and a cup of tea. So she was really good and really organized for us. So thank you. My name's Ian Greenway. I'm here as a climate change lead for the Department for Communities. So that includes obviously housing issues and many others across the department as well. Hopefully over the next 90 minutes, you'll understand why we feel this is such an important subject and one that needs further unpacking and explanation. And I want to thank, apart from Amy, the organisers and the other speakers this afternoon. There is a Q&A function at the bottom of your screen. Certainly it's at the bottom of mine. Please feel free to type away questions. And indeed, if you wish answers to those questions as the session goes on, we will pick out some of those then towards the end we will make sure we have at least 10 minutes Q&A at the end, and we'll pick some of those out for the panel to answer, or rather I will pick them out for other members of the panel to answer using the chair's prerogative here. So I'm going to start with a brief presentation just to set the context, and then we'll be passing on to other speakers. So let me just start this brief slideshow off. This is our schedule for this afternoon. So I will be passing on to Professor Aoife Viberg from Ulster University to give us a keynote address, and then Barry from Southwest College will set that in the context of an example, and a very good example in Northern Ireland. And then Aoife will do some looking forward before we get to the questions and answers. So why are we talking about this at all? Why are we all here this afternoon? Well, we have now got a very demanding Climate Change Act in Northern Ireland. It sets targets beyond where the science can currently get us to. It's certainly a good definition of a stretch target. And you can see on the chart on the right of the screen that buildings account for a big chunk of that carbon, 14% there for residential and how it's split up. But you'll understand that some of the other parts of that pie chart include buildings apart from just the residential. So this is a significant part of our overall climate change challenge in Northern Ireland. And this is a straightforward, simple, apparently, diagram. And thanks to Robert Clements from the Housing Executive for bringing it forward. And you'll see in the middle of that is in-use carbon, operational carbon. That's part of a much broader life cycle. That in-use carbon, we've been looking particularly at heating, for instance, and how do we decarbonize power? How do we insulate buildings? But the diagram shows that is one part of a much broader piece of the impact of the carbon created by an individual building, and indeed of all buildings. And the Act compels us to net zero carbon for Northern Ireland, all types of carbon, by 2050. This diagram shows it, a very similar thing, but in a different form around a loop rather than in those building blocks. And you can see the operational carbon going, as I would say, from 8 o'clock to 10 o'clock on that loop. And you can see Carl Elefante's statement. As with all of these statements, it's perhaps oversweeping and an overgeneralization, but certainly we need to see the whole life, the whole cycle, and that probably hasn't been focused on sufficiently. If I just take that back to the example we're going to hear about the Urn campus, and Barry's going to talk about the tremendous world-leading work there to create a a further education passive house standard building. But what was on that building site before? It was a 1960s hospital. That had to be demolished. What was the carbon impact of that? Before that, my day job is as historic environment director, so I have to go backwards some distance in time. There was a Victorian workhouse and workhouse complex. Some of that is still there and is being converted by Southwest College into a skills centre and into business accommodation. The college moved from the centre of Enniskillen, and there's an empty building there now. There are buildings on the Heritage at Risk Register now as a result of that move. Many of those things were potentially necessary, but I simply use that as an example to say there's a much broader canvas we're working with here. And here are some points perhaps we can all think about as we hear the presentations and the discussion, including what leadership role we want to have, whether we work in the public sector or the private sector or the third sector. What is the role we want to play in getting this broader understanding, this broader focus, and indeed then this broader action to deliver on what we know we need to deliver for the planet as well as for legislation? What do our baselines look like? How do we audit to know how we're doing? So hopefully this slide will give you a few pointers to think about, things to reflect on as you hear the other presentations. And a couple of slides very quickly to give you a sense of the broader pieces of work the Department for Communities is doing and how we're doing them. Departmental Management Board, DMB, as it says there, is actively interested and recognises its responsibilities around climate change, for instance. There has been some funding to move on with some electric vehicles and some solar panels, for instance. How do we connect with our arm's length bodies, not just the housing executive, but museums, libraries, arts council, sports council, and so on? And how do we bring the skills piece, another part of DFC's world, into this space? And here, another broad view of all of those things we need to do in our grant conditions. The pension scheme, NILGOSC, has £8 billion of investments. How is that playing its part in climate change? So that has hopefully given you some context. And it's a pleasure for me now to introduce Professor Aoife Weiberg from Ulster University to get us into this subject more fully. I'm going to stop screen sharing and hope that I see Aoife emerging from her bubble on the screen. Aoife, are you there? Yes. Over to you, Aoife. You okay there? Yes, there we go.
Okay, are we live?
We are.
Okay, so I'd like to welcome everybody to the Embodied Carbon workshop. So we're trying a little bit of an experiment here. So we have 110 delegates online, and we're trying to Zoom this together with you. So I shall begin. So my name is Professor Aoife Houlihan-Weiberg, and I'm Director of the Architectural Research Group at the Belfast School of Architecture at Ulster University. So today I'm going to talk about embodied carbon and net zero greenhouse gas emissions in buildings and communities. So it's really about knowledge building for industry and academia. So I want to just begin by setting the talk a little bit more in the broader context. So what are we doing internationally? And then I'd like to just showcase a few definitions. You know, in different countries, we use different definitions. And then I'd like to move on to what do we mean by embodied carbon, and then finally give you a showcase from Norway on the definitions, methods, and an introduction to the pilot projects. So as you all know, we have a climate emergency which has been declared worldwide. And this has now been implemented into many local governments and jurisdictions. So a lot of this has been already covered by Dr. Adrian Pugsley, but just to reiterate that the reduction of energy use and greenhouse gas emissions in the building sector is an urgent priority to limit global warming to less than 1.5 degrees centigrade in this century. So in response to this, a climate emergency has been declared. But I'd like to just begin with what do we mean by a climate emergency? So this is defined as a situation in which urgent action is required to reduce or halt climate change and avoid potential irreversible environmental damage resulting from it. So the global impact of buildings, so building construction and operation accounts for almost 40% of global final energy use and almost 40% of energy-related CO2 emissions. So therefore, improving the environmental performance of the building stock and developing zero-emission buildings are really critical to avoid an increase in energy use and greenhouse gas emissions. So in the UK, a law has already been passed for net zero emission by 2050. So it's become the first economy in the world to do so. So it's not the only country. Every country in the world is really engaging and developing its own pathway and definition. So I'm just giving you a flavor of some from around the world. But what you can see also, for example, to bring it a little bit closer to home, you have the UK Green Building Council, which is, you can go onto their website and you can see that they give a definition on net zero carbon, and they do these really nice country profiles. So you can just click into Advancing Net Zero Snapshot and look at the different approaches around the world. So that's very accessible, and you should definitely share that with your organizations. As well as that, we have LETI, which Adrian spoke about already, and what they've developed is a really easy to understand embodied carbon primer. So again, we'd recommend that you go onto their website. It's very easy to understand, and again, sharing it with your organizations. But, you know, with all these different pathways and definitions around the world, of course, it's starting to become a little bit of a Wild West, and it's a little bit confusing, I think, for organizations to really understand which pathway should we be following, what is really understood by these definitions. So I won't go into too much detail here, but just to let you know that I'm part of this International Energy Agency, Annex 72. And within that, we have a work package where what we have done is to conduct a survey of all these definitions around the world. And what we're trying to do is to firstly get an understanding of what does that definition mean. For example, what are the boundary conditions that are included? Which metric are they using? Are they talking about energy only, or are they including embodied emissions? And what we want to get out of that is try to develop a more transparent and standardized approach. So it's like an international definition framework, which different organizations around the world could refer to. And the idea then is that having a more standardized approach will mean that we'll have less misunderstandings and we have more reliability in those definitions, and hopefully avoid greenwashing. So out of the 35 countries that we analyzed, what we found was that 22 of the 35 have definitions in place that are focused on zero energy. So those are shown in blue. But equally, what we found is that we have 13 standards from 11 countries which have made that shift to a definition for that's including greenhouse gas emissions. So that's a really positive step. again, there are 33 different schemes. I won't go into it, but just to give you a sort of a flavor and a highlight, I've taken 4 countries here, and you can see that the definition is different. Some are talking about zero carbon, some are talking about zero energy, some are talking about net zero emission. So what that essentially means is that in some countries we're talking about just zero energy, and in others they're talking about including emissions from operation and embodied emissions from materials. So there are 2 different pathways. And some are dealing and calculating with that on an annual basis. Some are dealing with it over a 60-year period. So it's just to highlight these differences. And what is interesting is that all of them are actually voluntary at the moment. And what we're seeing also is that a lot of the initiatives are coming from industry or research councils. So there's a real opportunity for industry partners and research organizations to actually be making a difference and leading the way. So this is just showing you, the different building standards and schemes, and these are all the ones that are referring to greenhouse gas emissions. But even within that context, you can see those different definitions. Some are terminology, some are using zero carbon, some are talking about net zero emission. But the main recommendations from this is, regardless, there's a lot of momentum, there's a lot of initiatives worldwide, but all of these standards need, or schemes and approaches need standardization, and we need to start integrating this into national and local policy. But another key thing that we found is that different countries are at different stages of the game in terms of what they can practically do. So it's really important to have that framework and have flexibility within the framework. So different countries can all make a step, but at different stages. And then finally, that, in terms of compensating for the emissions that are used in a building, that we shouldn't just focus on on-site compensation, because this isn't always possible to do at a building level. And sometimes, that's more applicable for new buildings, but many countries are dealing with a lot of existing buildings. So we need, again, more flexibility on the possibilities. So you can read more about this on the link attached. So that's just giving you a little bit of a whistle-stop tour to the international perspective. And then I just wanted to really now start in the second part on embodied carbon. So what do we mean when we talk about embodied carbon? So we define this in the IEA as the energy used in and the greenhouse gas emissions from manufacturing the construction materials, constructing, maintaining, refurbishing, and demolishing the building. So that is basically visualized with that image, the small diagram on the left. So everything included in the red circle is to do with the embodied emissions. So it's everything from taking the materials out of the ground, transporting to the factory, processing in the factory, transporting the material then to the site, which could be in another country. So you've got transport emissions. Then you're starting to construct it in the building. Then at the end of the life of the building, you demolish it, and then the further use. So all of this is the embodied emissions. And then, of course, we have the emissions from operation. So this has also been touched upon already, but just to let you know that, when we calculate embodied emissions, we call this the life cycle analysis, and we do this according to standardized approaches. So this is showing you the standard that should be used, EN 15978. And what you can see there is you can see A1 to A3 are the production phase emissions, A4, 5 is transport and construction emissions. Then you have the use stage emissions, so they're B1 through to B7, the end of life, the C modules, and then the benefits and loads beyond the system boundaries. So that means if your building was deconstructed, if it was made out of timber, you may decide to send the timber to a waste facility where the timber is burned and that waste heat is used for heating a neighborhood. So that's kind of the next steps. So how do we measure this? So what the unit that we use is kilogram of CO2 equivalent, and that can be, you know, per functional unit, which is per meter squared, per meter, per kilogram, etc. And why is this important? Because for designers and other stakeholders, it's really important then, if it's, you know, particularly integrated early in the design process, then we can see what the impact is from the different components used in a building. So that's very useful if this is done early in the design process, because you can go back to the drawing board if you start to see certain materials or components are driving high emissions. And again, this has been touched upon already, but just to let you know, as we're shifting towards net zero emission buildings, they're becoming more and more highly energy efficient. And how they achieve that is using typically materials, how do you say, the burden is shifting more to the embodied side. So what we see in zero emission buildings is that the emissions from operation is being reduced, but the burden is now shifting to the embodied emissions part for the materials used in the building and all the technical systems. So why is this interesting? Well, it's interesting because if you're only looking at balancing the energy demand and you're not considering the embodied emissions of the material part, then you're missing so much, how do you say, the bigger part of the picture. So that's why we need to make this shift from thinking about nearly zero energy or net zero energy to a more life cycle approach. So, and another interesting thing when you do, you're calculating embodied emissions and the LCA, is then you can start to see a picture as well of where the emissions are happening in the life cycle of the materials. So what you see, for example, if you do your LCA, is that you might have chosen materials that have high embodied emissions in the production phase. And so then you might think, well, okay, that could be concrete or any other material. I'm not saying just concrete, but it could be a material that is energy intensive. And then you might look, oh, could I use a less intensive material for those production phase emissions? And so you help to reduce that part of the life cycle. And another part is, for example, as a designer, instead of choosing a material from far away, for example, you may choose materials closer to your site. So you've got an opportunity then to reduce the emissions from the transport phase. So, or instead of a highly technical or intensive production phase material, you might switch it for a more natural material like timber or something else. And again, you can reduce the emissions for that phase. So very simplistic diagram, but essentially, how do we connect the two? So you have the embodied emissions, let's say calculations and results here on the top right. But how you're getting that is you have a model or a design, it could be a 3D model, and you have all the different materials, and then you're getting a visual picture of what that means in terms of environmental impact for the emissions for the materials. So you start to get an idea of what is the impact from, you know, the materials that I've chosen for the skin of the building, for the technical equipment, could be mechanical and ventilation systems. So what you can do then is, if it's done early enough, then you can go back to the drawing board and switch out those materials that might be driving high emissions, and, you know, sort of do the sensitivity analysis for other materials. So how we do that is we tend to connect our 3D models with, you know, databases that have all this information on embodied emissions. And I'll go in a little bit on this, but you can use generic data, which is kind of more average data, particularly in the early design phase when you don't really care where exactly that particular material is coming from. But as you go further into the design, you may wish to switch it for specific data from what we call environmental product declarations. I'll go into that in a minute, but essentially what we need to do any embodied carbon calculation is we need material quantities. So you can typically get that from a 3D model. But what I like to say to students is that you shouldn't rely on just, tools available online. You really need to understand from, the basics. So you can actually just get quantities from a drawing. You can measure quantities for a wall or an area of wall. And then if you know where to get the data from the environmental product declaration, you could do the calculations yourself. But then the idea is that you have a rule of thumb to make sense of what those numbers mean in the tools available online. So this is, in a nutshell, how we, very, very simplistic, but essentially you have quantities of materials. You need to source emission factors for those materials from an EPD. And then you multiply them together to get the CO2 emissions. There's a lot more in this than what I'm saying, but just so that you understand the concept. And we get our data from different sources. These are just a selection, but in the ZEB work in Norway, we were using EcoInvent. It's a Swiss database. But more and more the EPDs have come on tremendously, and I'll just show you a little bit about those in a second. But the beauty is, generic data gives you one result shown in, the red. But when you switch for more specific data from a specific factory, then it's giving you more accurate data. So what we found when we recalculated using both was that the specific data from EPD showed less emissions in the results. So this is just showing you results from one of the pilots. So this is an EPD, and I'll go through a little bit about that. Are any of you familiar with environmental product declarations? Yeah? Oh, well. So there's no, industry partners, manufacturers, I mean, that's a really terrific source of information for us. And you don't need, you can read through this in your own time. But essentially, an environmental product declaration is a document which transparently communicates the environmental performance or impact of any product or material over its lifetime. So this is just where can we find reliable, EPDs. So we refer to Eco Platform, which is a really great source. Anybody who is signed up and verified through any of these will have to follow and meet stringent requirements, product category rules, it's third-party verified. So it's a very reliable source of data. And that's really key when we do our calculations, because if people are just taking data from wherever, then that can really skew the results. So it's very important that you use accurate data. So you can use Eco Platform, and you can also refer to the International EPD system. So I've given you some web links here. And just without going into a huge amount of detail, what do they actually look like? I mean, they're very comprehensive. They're about 16 to 20 pages. But essentially, for designers and students, it means they can look. There's usually an EPD library, and you can choose, insulation material, click on that. Then you can go in and, I want to look at rock wool versus, I don't know, some other, it could be sheep wool if they have one available. And it's really terrific because they're following that standardized approach. And they're just really looking for key information, the functional unit. I won't go into too much detail on this, but essentially you do need to know the functional unit. So the square meter is the typical 1 meter squared. It usually gives you information on density, etc. And we typically like to know where is it from, because that can have an impact on the transport emissions and the electricity mix that has been used to make the material. And what we typically say is we like to use EPDs that are as recent as possible, because that takes into account the decarbonisation of the grid. Okay, so essentially, you have other impact categories which you can choose for. We tend to use the top left, global warming potential, and then you have your figures for different life cycle stages. So I think I need to move on to the next part. So that's kind of the nerdy bit done a little bit, and it's just a whistle stop. So, okay, so what does this mean in reality? Well, I thought I'd like to showcase what's been done before. And so a lot of the work that's been produced here and that you're exposed to is coming from the Research Center for Zero Emission Buildings in Norway. So we're very grateful to the Research Council and to ZEB and ZEN. So essentially, I touched upon this for those in the room, but not for those online. But Norway wants to become zero carbon by 2030. And to achieve that, the Research Council has funded these different research centers around the country, each looking at a particular pathway to delivering net zero. So the one that I was working in was the zero emission buildings one. So the main vision of the ZEB, which is building scale, ZEN, neighborhood scale, is essentially to develop sustainable neighborhoods with zero greenhouse gas emissions. And how this is done is through reduction of greenhouse gas emissions, making buildings that are more energy efficient, using local renewable energy production, trying to reduce the amount of materials that we use, and obviously the energy use, and to use more environmentally friendly materials and try to reuse materials as much as possible. So what I want to show here is that Tech 10 is essentially the building code. It was, let's say, a starting point. This was actually done 2009. It's quite a long time ago. But in Norway, there was energy consumption at that time. Then improvements were made in the building code, which was done in 2010. You can see the reduction. And then in 2017, the Passive House standard was introduced. That helped to reduce the energy consumption even further. So essentially halving the energy consumption. But the big shift happened with the introduction of Tech 20, which was the nearly zero energy, and the building code was introduced. And that was where we started to really change from thinking of buildings as energy consumers to prosumers, so producing more energy than they use, and doing that through on-site, it could be PV, for example. So then what you're seeing in green is the on-site production from renewables, so that could be photovoltaics. And what you're trying to do is to basically balance the production or the demand, the energy used in the building, with a green supply. In this case, it's normally done on site. But then in 2025, the zero energy code was introduced. And there, what you start to see is that buildings started to produce even more than they were using. And then that was then put back into the national grid. So the more ZEBs that were created in the country, that obviously helped to decarbonize the national grid. So that I thought was important for you to know. And again, I don't have time to get into too much detail, but just trying to visualize this. So the red part of the column is really the emissions, the energy used in the building. And what we're trying to do is to balance that with a renewable on-site. And where you meet that balance between demand and supply is the lowest ambition level in ZEB Center, which was called ZEB-O, so zero emission building for operation. But then, like I said, some buildings lend themselves to having more renewables on the roof, but it could be on the facade of the building, it could be in other opportunities around the site. And what you see is that the buildings then are able to produce more than they're using, and then they become a plus energy building or a net positive emission building. There's a lot of different terms. But what we see then is you then want to include all the embodied emissions for the materials used in the building, the blue part of the column. And so therefore you can see you need to increase the green part to match the blue and the red. So you have to start to think of a little bit outside of the box and really integrate that where shall I put my renewables, early in the design process in and around the site. So there's a series of these increasing ambition levels here, which I've shown across the life cycle. So you've got balancing for the energy, operational energy, ZEB O, operation and material OM, COM is construction, operation and material, and then the holy grail, construction, operation, material, end of life. And in a more simplistic way, it's essentially the green circle is showing the renewable production. And you can see the green circle is much bigger than the orange circle, the energy emissions from operation. So that's a kind of plus energy, plus emission building. But what we want to do is to balance all the embodied emissions across the whole life cycle of the building. So all the orange circles need to be, the green needs to be more than that in a nutshell, essentially. Right, so, and again, not too much detail, but again, it's going to be really important for you in Northern Ireland to understand the grid mix. What are the plans for decarbonisation of the grid mix? Is there any exporting and importing of electricity in and out of the country? Because that really can affect the emission factor that you need to use. Okay, so why is this important? Because the results from these built, and that's a really important word, like the fact that they're built, it's not theoretical. So the buildings, the pilots have been built, and what we see is, yes, the energy consumption is going down, but that's been achieved through greater embodied emissions from materials, so the grey part. So that's what I'm just reiterating. If we don't consider and introduce policy and consideration of embodied emissions, then we're missing a huge part of the picture. And when we do, these calculations for embodied carbon, it's really useful for us anyway as designers, students, etc., to then, see where are the high drivers coming from emissions. So typically in the ZEB Pilots, repeatedly those were coming from the PV. Typically concrete was used in the foundations, and then EPS insulation, because it can get very cold. So it's very important to have really good insulation to the foundation, sometimes the roof. But just because they're high drivers, it doesn't mean that that's necessarily bad. It's just good to know. And then you can make, as a designer, concerted efforts then to choose other materials in the rest of the building that have much lower embodied emissions. Because you actually need the PV to create the ZEB in the first place. You need the concrete for the pad, or it could be strip foundation, but you can start to look at alternatives. It could be blue concrete or other alternatives. And I think I really need to probably move on now onto taking the research to real buildings. So just the ZEB Center was the predecessor to the Zen Center, which is focused on neighborhoods. And I'm not going to have time to go into that today, but the ZEB Center ran for a period of 10 years. So it's really important to build upon and share that knowledge rather than reinvent the wheel, because the definitions have been created, the calculation methodologies are there and the pilots are shown. But everything will be different when you start to adapt that to different contexts worldwide. And the big thing that made it such a success was it's multidisciplinary. So all the actors and stakeholders are involved from inception. They're invested in this development. It involved a lot of, municipalities, industry partners, architects, etc. But everybody was around the table from the beginning. And, the main objective of ZEB was to create solutions that could be implemented today. So it wasn't creating solutions that were so expensive or so technical that you couldn't actually implement it into the mainstream. So that was a really strong prerogative for the center. And the main thing was that they created a net zero greenhouse gas emissions across the whole life cycle, and to build real buildings so people knew how to build and deliver this in practice. So the centre developed these pilots, which showcase typologies for residential, commercial, and public buildings. And you can look at the website for more information. And the centre was organised, it varied in scale. We had to start with the definition, and that's something I'm really urging in Northern Ireland, elsewhere, have a really good, clear definition to begin with. So we're all knowing which goal we're aiming for. And we all need really good calculation methods, so we understand how to do this, and we're using reliable data. And then, it ranges, developing materials in the lab, scaling up, developing new components, having living labs or test facilities where, industry partners can come and actually test and see these new materials being developed, and then making the bridge from theory to practice. So having pilots that we can really bring all the research together and showcase how is that delivered in reality. So the pilots were such an important part of the ZEB and ZEN Center because they provided an innovation hub where researchers, industry partners, students could come and really be inspired to be in a real building that is a ZEB. And it also helped to verify the theory because, you can do the best simulations, but in reality, the actual consumption, et cetera, is always different. And that actually is really influenced by humans and how we use buildings. So it's important to have living labs where we can test human behavior and energy consumption. So the 10 steps to ZEB is something that I've been drilling in to the students, but I think it's useful as a sort of a stepwise approach. I won't reiterate it here, but this has been developed by a colleague of mine, Inger Andreasen in Norway. And it's a really nice, stepwise approach to delivering a ZEB. And the main point is that you start with passive design, so proper understanding how a building sits on the site, understanding the potentials for solar gain to the south of a building, whereas to the north, maybe you want smaller openings, maybe you want more thermal mass, so you have less heat loss through the building, but just really kind of getting back to basics of good orientation, form, etc. And so the biggest priorities are really put on passive design in the beginning, and then good material choices and reducing the energy consumption as low as possible. But you kind of always need a bit of energy in the building. So then when you get it as low as possible, you try to balance it with renewables, those active systems that Adrian has spoken to you about. So then you have all the different ZEB pilots. These are the ones, like I said, for building scale. And there's a new research center that's been running since 2017 at neighborhood scale. So there's 8 neighborhood scale pilots you can also look at. But these, you can just go onto the website zeb.no. And what you can see is the middle column is showing you the different typologies. So it's really good to kind of look for a building that's similar to what you're planning. But you can also see they range in size from, it could be 100 square meters to 80,000 square meters. So a quick 1-minute video, if it works. Let's see, I don't know if I did the share video computer sound.
In the last 150 years, the global average temperature has risen by 0.6 degrees Celsius. In the Arctic, the temperature has risen twice as fast. This is man-made, and our emissions continue to increase. Norway's emissions per capita are double the global average. We must work together to reduce our climate footprint. To do this, we must make conscious choices before it's too late. It takes a vast amount of energy to build, run, and demolish a building. Buildings account for 40% of global energy consumption. That is why, in order to adapt to climate change, we must build smarter. Building smarter not only saves the environment, but also money. And most of the technology we need already exists. With Powerhouse, we have created a building that will produce more energy than its total consumption, from cradle to grave. See how we did this, and how we can change the way we live and build.
Okay, so let's see. I think I only have about 3 minutes left, so I'll just show you very quickly this ZEB pilot, and then I think I need to call it a day. But this is just, it's a sort of demo building, a live living lab. It's a residential building designed by Snohetta. And what you can see here is that, and this is quite typical, I would say, of approaches to ZEBs in Norway. So one thing is the buildings are typically orientated to the south, 15 degrees off south. And then the form of the building typically has roofs that are angled to the south. And that allows you to put the PV on the roof, but it can also be on the skin of the building. So this one, what you're seeing is you have photovoltaics for electricity generation, but you can see that the plan of the building then starts to get quite deep and dark. So what they did was they cut out this atrium into the center, and that allowed daylight to get into the middle of the building, so you use less electricity and have more natural light. You can see there's solar collectors in the middle part, and this was connecting and allowing hot water for the building, but also they used an old shipping container for the swimming pool, and then that heated the water for the swimming pool. There's many different technologies here. So you have a combination of the photovoltaics, solar collectors, ground source heat pump, and then they collected the rainwater, etc. I think I'm going to have to really wrap up, but they had a large area in the center of the building that needed thermal mass. So originally they had thought about doing that in concrete, but obviously that was quite high carbon. So they looked at a blue clay concrete, which uses clay from around the site, which reduced emissions. But in the end, actually, they went for reused brick from a site nearby. And that gave a real character to the architecture. And they used this wood from nearby the site as well. So the main thing is this building demonstrated ZEB OM, so it balanced its emissions for operation and material, which was terrific. And then I have some other solutions, but I think, am I really at the end now? Probably, yeah. Yeah, I'll show you one last video and then I'll just leave it there. Yeah. So this one is nice. It's showing you a retrofit of an existing building. And then...
By combining and optimizing existing technology in new ways, an ordinary office building from the 1980s can produce more energy than it uses. The key phrases are new ways to work together, competitive prices, and practical sense. In Sandvika, the Powerhouse project is completely changing how we view buildings and energy. The construction industry and existing buildings account for much of the energy consumption in Norway and around the world. In fact, 40%. Energy use and emissions are units that are closely correlated. By combining very low energy consumption with local energy production, office buildings can become a source of energy, a part of the solution. Powerhouse is a partnership established by the environmental organisation Zero, Entra Eiendom, the contractor Skanska, the aluminium company Hydro, and Snohetta Architects. The ambition is to develop and realise buildings that produce more energy than they consume over their lifetime. As far as we know, Powerhouse Sherbo is the first project in the world to transform an office building into an Energy Plus building. The building will be finished being converted in February 2014. Asplan Viak is the technical consultant and will also be the tenant. The project has shown that it is possible to reduce the energy consumption by 90%. Reusing concrete constructions and other components provides substantial energy gains. Heating is energy intensive. Reuse of ventilation heat is therefore vital. Concrete surfaces are good for even temperatures. Knowledge of materials, new and old, is vital for realizing smart solutions. At Cherbourg, energy wells in the ground provide energy to the heat pump installation in the winter and cooling in the summer. Solar power produces ample energy, around 200,000 kilowatt hours a year. This is more than enough to cover the demand for energy. The power can be supplied not only to the buildings, but also to the power grid. Energy wells and district heating contribute to the heating of hot water. Walls, roofs, and windows are planned with extremely good insulating properties. The building's overall need for energy, heating, cooling, ventilation, and lighting is very low. And the result will be like this. Externally, we have retained the original expression in black. Burnt wood gives a natural and maintenance-free facade with lots of light. In the project, we have found new architectural concepts that integrate technical solutions and use materials that insulate and ensure a good interior temperature. Despite the building's large output of energy, there will be a periodic need for input of energy. Powerhouse Cherbourg is being built using existing technology and available expertise at a competitive price. The really clever solutions come from the new cooperation processes. Powerhouse Cherbourg is a unique project, but it is fully possible to use the concept in other transformation projects and on commercial terms. Instead of being a challenge, buildings can be a part of the solution.
And I think that's a perfect ending. So thank you so much.
Thank you. Golly, audience feedback as well. We forget what that's like in these virtual meetings. So that's brilliant. Thank you very much, Aoife. I am going to move us straight along. There's enough to explode my head anyway in that, but I'm going to move us straight along to Barry McCarran from Southwest College to give us a more local example as well. And then we'll come back to Aoife about the way forward. But to keep us on schedule for a half-3 finish, I will head straight over to Barry.
Barry, you're on mute there as well.
Thank you. If there was a pound for every time we heard that. Okay, so yeah, I'll just introduce myself. So I'm Barry McCarran, Business Development Manager here at Southwest College. And a significant part of my brief here would be managing research and development projects with a team of approximately 20 staff. And we would be doing, engaging with industry and doing work similar to actually that centre in Norway in many respects, just at a micro level here in Northern Ireland. And some of the recent projects we would have would be in the whole area of embodied carbon and carbon counting with some of the concrete companies as well. So I'll try and pick up these strands as we go through and dovetail with what we've seen from Aoife in the first presentation. So today's presentation really kicks off with the new building that we have in Southwest College, and I'm conscious of time, so I'll move over some things just with the respect to urgency. So this is our new Earn Campus building in Enniskillen, and it's the world's largest passive house premium building. And as you can see from the picture, I don't think I'm gloating or over-egging it by saying it's a beautiful building. I'm also quite conscious, considering the subject today, that this is a new building. So there is an embodied carbon consideration there, and that's not lost on me, and I'll pick that up as well as we go along. So like Aoife was saying, you know, buildings account for approximately 40% of emissions. The typical breakdown that we normally get, of which today is trying to illuminate the other aspects to it. You know, operational energy is coming in at 29%, embodied materials coming in at 11%. And very much what I'm going to talk about today is how the Passive House standard in particular combats operational energy, and then looking forward where the Passive House Institute in Germany, along with ourselves in the college, is actually now turning our attention towards the other 11%, the embodied materials. So again, I just want to pick up a few things that maybe people don't know as well. Passive House is actually written into the UN when it comes to climate change. The UN FCCC, who are responsible for the world's approach or combat on climate change, have written into a number of various reports the Passive House standard, saying that it's a really good mitigation tool for governments and policyholders to adopt going forward. So there's a number of the reports there mentioned as well. Also, I would say that sort of like what Aoife was saying as well, Passive House is very much the first building block. And in the NZEB approach across Europe, you will notice if you actually drill into the numbers, and for my own PhD, I had to do this in the literature review. If you take the 15 kilowatt hours for Passive House and you add on a domestic hot water demand, that brings you to the figure of 45. And that 45 is the same figure that's advocated for NZEB across Europe. So it's there in the genesis at the back of it all. So again, if we move forward, I just want to sort of talk about why the Southwest College went after Passive House and how that all came about. The first thing is to say that this has been about for 30 years now, this year gone past, actually 31 years now as we're into the new year. And it's the fastest growing building standard in the world. It's known for its energy efficiency all over the place. And for us, it was also an opportunity to do best practice, but to also try and wrap into it opportunities. And that's working really well for us to date. The other thing as well, which again, it's a bit of a myth that people would have about the Passive House standard, is that, and it's one of the things that attracted us to it, is that it's an open source standard. So if you want to do it, you don't really need to engage with the Institute or anyone. Everything out, all the information you need is out there and readily available as well. So again, I'm just, my keyboard and mouse are in two different pathways here. Yeah, so underneath the standard, if you like, the whole realm of Passive House, there is 5 classifications within this. And what's really good about Aoife's presentation and me, and we didn't rehearse this, is that there's a synergy here. Aoife was talking about the tech standards, Tech 10 right through to Tech 25 in Norway. And again, I can see a complete synergy in what I'm about to talk about. The 5 classifications of Passive House start off with a Passive House low energy building, which is just below Passive House Classic, where they relax the air tightness level that you can achieve, and also the numbers that you have to hit in terms of kilowatt hours. And then you've got Enerfit, which is the retrofit standard, and I myself here at home, I'm about to embark upon that journey, retrofitting the house that I'm sitting in. And then on the other side of it, you've got, and again, this reflects what Aoife was saying, you have Passive House Plus and Passive House Premium, and that's very similar to Tech 20 and Tech 25 that was mentioned in the previous presentation. So I'm going to talk a little bit more about them because our own building is Passive House Premium. This is a little bit that I worked on this morning around future building standards, and something I want to try and illuminate, and maybe people will want to engage with this afterwards in the discussion. It's really important, I think, from my perspective on what learning we've had in the college with respect to our journey, that we really understand where we're at with building regulations. And this just isn't a Northern Ireland drumbeat. It's also the UK and in Europe. Passive House is still better than most building regulations across Europe. But we've seen, you know, a big example at the start of Aoife's presentation about the 1.5 degrees. We've seen COP26 at the back end of last year. The climate change imperative is right here staring us in the face. And you know, our building regulations are not enough at the moment. If you're building a new building today, and this was the approach the college took, was if you have to build a new building, is the first thing to say, probably in light of the topic matter here, but also it has to be a building that's not going to be retrofitted in 10 years, 15 years, or 20 years. It has to be the best that you can build today. And that means going above and beyond probably the building regulations. And I think we need to reiterate some phrases like the building regulations is the minimum standard. That's what it's there for, the minimum standard, not what you're supposed to build to, and that's it. So if you're conscious and progressive, the Passive House standard is there to build to, and I don't think you'll end up the wrong side of it. So what this little graphic has here at the bottom is sort of showing us, you know, about energy and what Passive House does there. Because it reduces the energy demand to such a low level, that means that your micro generation or your renewable energy that you might bolt on to your building either at the time of construction or later on, you need less of that, which means less money. And you'll get the energy then that's produced there will most likely cover your energy demand. And all of that's really good. And then if you're looking at it from a government policy point of view, that's also the same thing. The grid is being decarbonized, you know, in each country across Europe and the world. And then as well, if Passive House is adopted on large scale, then that means we've less grid demand as well, and there's an opportunity there for balancing as well. So it's a really interesting space, and I'm aware there's some students on the call as well. This is a really good time to be a student. You know, this whole embodied carbon conversation that we're having today is a huge opportunity for you guys, and also low energy building going forward as well. You know, and I'm really glad that I'm in this space with my career as well. And you'll also see in the other standard here that just exactly where Passive House Premium and Passive House Plus really deliver with respect to some of the other building standards. The others are all good, but this really is best in class, is what I'm trying to say. Another thing I want to talk about with respect to Passive House is also how there's a change here as well. The Passive House Institute in Germany sort of feel like they've got operational energy sorted. The Passive House standard will deliver all of that. That's already proven and all of that. And there is a focus and a shift from them into embodied carbon. And the latest tool that they've had now for about 2 or 3 years, and this was developed in the UK actually, is a software called Passive House Ribbon. So if you're using the tools PHPP, Design PH, and SketchUp, this is just almost a click of a button or a couple of clicks of the button, and you have your embodied carbon data alongside this as well. And we heard there as well from Aoife about the integrity of the data that is inputted. And this is something that's a huge success with the Passive House Institute as well. In their PHPP software for general energy calculations, they always make conservative assumptions and make calculations that are not optimistic, which means that you don't end up with a performance gap along with a couple of other things. But when it comes to the whole area of embodied carbon as well, this is also an area where we seen earlier with Aoife as well, that there's an opportunity to not cook the books as such, but the information that you put in is very, very important. And what happens with this PH ribbon is they are using the most conservative data and conservative assumptions when we're calculating CO2, which means that you probably end up with a true figure as well. So I'd expect with this software, you won't end up with a performance gap with respect to embodied carbon as well. So for us in Southwest College, all this started back in 2015. We built the Crest Centre, and that's at our skills centre in Enniskillen town, just outside the town. This was part of an EU project. It was not seen as a free hit, but we were the capital, we were the lead partner on the project, which meant we had a capital build, and it was an opportunity to do genuinely best practice. And we put our best foot forward on that, and it's been an excellent success for us. Now, you could say that this was in effect a pilot building, and that's what it was when we consider where we are now with the Earn campus. So this was a £1 million project, and it led to, and it really helped the business case with some of the post-occupancy research and all we did, to securing the £30 million Earn Campus, which is Passive House Premium. It also allowed us, in my department of business development, get on to becoming an agent for the Passive House Institute, delivering their tradespersons course, their designers course, and now their site supervisors courses as well. And we have about 300 people trained in that in Northern Ireland. They're quite modest numbers, but in the Northern Ireland environment, that's still quite strong. And then I suppose just to show you the before and after, if you like, of what we have done, I have to show you the before. This is our existing college campus. It is, as you can see, a building of its time. I personally think there's a great opportunity with this building for a retrofit, because if you put your Passive House goggles on really and look at it, the form of the building is excellent. And because it's a concrete framed structure, everything there is perfect. When you strip off the cladding, all you have to do is reclad it, reglaze it, and you're probably almost there, coupled with some ventilation systems and M&E, you know. But as it's currently sat in its last 3 years of life, it was using almost 100,000 litres of oil a year, and costing the Northern Ireland taxpayer at the time. We now know what oil has gone up dramatically, but you're talking about £51,000 a year to the Northern Ireland taxpayer with respect to heating that building. And then I suppose our aspiration was to build a world-class building. If we were going to do it, we wanted to be world-class, and we also wanted to have the best in practice. Now, I suppose if there was one thing that was left out, it probably was, you know, other considerations around embodied carbon. You know, more could always be done in these things. And again, I can pick that up in the discussion, but it is BREEAM outstanding as well as Passive House Premium. So that's a good combination amongst the two of them. And then the predicted performance of the Earn Campus, and it's going to get better and better as oil prices go up, fortunately as well. The building comes in at a really, really low 8.4 kilowatt hours per metre squared of floor area, which means, if again, some of the numbers here, you don't have to fall out with me on it. You can put in whatever figure you want and you get a similar extrapolation. If you assume 10 watts per kilowatt hour, it turns out that that's about £6,000 in terms of the heating demand. Remember, hot water is not included in that. And that in comparison to the 51,000 is a 44% or 44,000 a year saving, or nearly 90% when broken down. And if that's extrapolated over 25 years, for example, or a typical lifespan of 50 years, you're talking 1 million or 2 million in terms of saving. And that's very conservative as well going forward. So again, these couple of slides I'm just going to gloss over. I'm not going into detail with respect to U values and all the rest of it, but it is important to just toggle through them from the perspective of how it all works. There's 5 principles we say when delivering the Passive House training, and it really is these next couple of slides. So the first principle is your building envelope. So that's your floors, your walls, your roof. You need to do as well as you can do with your building fabric. So the lower you can go with the U values, largely with respect to these, the better. Another consideration might be the proportionate area of each of those elements. My own retrofit building at home here is going to be a bungalow, so I've got a disproportionate floor area to wall. So it would be better for me to put more insulation into my floor than maybe my walls. So it's just another thing to say. But number one principle is your thermal envelope. Number 2 is, if you're really enhancing that thermal envelope, the junctions become all the more important. So you have to consider thermal bridging. And really perversely, really in a real weird way, it sort of doesn't make sense. The more insulation you add, the more danger you have of mold and condensation here. So this is a really, really important aspect with respect to low energy buildings. And I would have a fear that some jurisdictions, if they adopt just an exclusive approach to U values and lowering U values, and they don't do enough on thermal bridging, there may be some issues with buildings going forward. A good example with respect to the Earn Campus is there was 4.5 kilometers of thermal bridging in this building. imagine that wasn't calculated like you're seeing in some of the pictures here. That would mean that's 4.5 kilometers of thermal bridging just left with heat running out through it. So it is a really important metric. Third is triple glazing. And you can see here in the energy balance, the bar graph at the side, that on the losses through the windows at the Erin campus, we're losing 22.3 kilowatt hours per meter squared, but we're gaining nearly 26 kilowatt hours. So we're just getting slightly, we're not losing any heat over the course of the year through our windows. We're actually gaining a little bit overall, and that's a key building block. A lot of people think that it's all about south face glazing. It's not actually, and that's what this little, if you can see my mouse moving here at the bottom, this other chart that I included also shows you each of the orientations. The one that's the most damaging is the north. So if you end up with significant glazing on any building on the north in this part of the world, it's probably going to do you more harm than you know, trying to really go mad on optimizing south glazing. But there is metrics you have to hit there for Passive House as well with respect to the glazing. So that's 3 of them covered. The last 2 go hand in hand. You make a building airtight in order to facilitate mechanical ventilation, and in particular for Passive House, mechanical heat recovery ventilation. I can't stress these 2 parts enough, and this is a common area to fall down with low energy buildings. You are making the building airtight. So if you just stop there and just absorb that sentence, to facilitate mechanical ventilation. And a good example of that is your car. You know, if you get up on a frosty morning, you're going down the road, the car is largely weatherproof and airtight with the windows up. But and if you turn on the blower in your car, which is recovering heat from the engine, same as the mechanical heat recovery recovers heat from the building. But if the 4 windows of the car are down, it won't matter how good that MVHR system is or that blower in the car, your ears are still going to be froze with the air getting in all around you. So it's really important to remember that those 2 go hand in hand. And for the Erin campus, one of the other things that was really surprising, it was surprising to me at the point in time that this building started, the bigger a building is, the more opportunity you have to achieve a lower air tightness. So the air tightness level for the Erin campus wasn't actually 0.6, it was 0.3. So that we got a really, really low air tightness, and quite easily. The contractor hadn't built the Passive House before, and they got this on the first hit. So credit to them, but it also shows what a big building can do and how easy it is. The MVHR system, again, this is a very complex arrangement here, and again, I've talked about it before, but I can talk about it again, and I can pick it up with anybody who wants to know about it. But largely speaking, we have this really innovative earth tube system, which will preheat air in the winter and cool air in the summer. There's a slide or 2 after this on it. And then we have an MVHR system, both centralized and decentralized. And then we have the atrium doing a little bit of purge ventilation if needed as well. So overall, it's been working really well to date. This is the earth tube system. It's basically a subsoil heat exchanger. There's over 1 kilometer of tubes out in the car park. And Ian mentioned at the start, our workhouse, you can see it here in the background on the site. It's going to be opened later on this summer, and it'll really add another bonus to our Erin campus, and it's going to be an excellent event venue. So I'm really looking forward to that being opened as well. It really will enhance the site. But these air tubes are just in front of it under the car park, and there's 1 kilometer of them. So as I said, they preheat the air at this time of year and they cool it in the summer months as well. So it's a nice innovative solution to have to talk about on site. The heating for the Erin campus is a combined CHP unit or a micro CHP unit, and we also have an air to water heat pump as well that services the atrium as well. So you're talking that the CHP unit is covering about 80% of the space heating, all of the hot water demand, which is quite significant, and then in addition to that, then the other 20% is picked up with the air to water heat pump. Then as well, you can see just from this photograph, not only does it show the relationship to the town, but you can see the significant amount of PV panels on the roof. And it's quite significant. Again, we can pick that up maybe in the discussion, but it means that for each meter squared of floor area in the building, we're generating 118 kilowatt hours. And the building's about approximately 7,000 meters squared. So the generation is quite significant on site. Yeah, there's the size of the system. It's a 520 kilowatt piece system for those in the know. The equivalent for, just to give you a proportion of size, it's about the size of 14 tennis courts up on that roof of PV panels. And some other nice photos. Again, we have significant battery storage in place as well to just sort of take the peaks and troughs off that system. And again, that's sitting at about 460 kilowatt hours of battery storage there as well. And again, you can see a screenshot of the PHPP software and how all of that means that we hit Passive House Premium. Yeah, on this slide here, I just included some screenshots of the Passive House verification page. So one of the things that I wanted to pick up was just where the heating load and heating demand comes in. Our overheating frequency, which I'll pick up in a moment, was at 2.6%. And then our non-renewable energy and primary energy figures as well are also really low. And that might be of interest to some of the people here who are really familiar with those terms. Overheating, I said there, 2.6%, which means the building has been analysed for overheating. That's a big plus of going to Passive House certification, is that you can model the building, and the best practice is that you get below 5%. You can actually design it out as well completely, but you will fail to meet the Passive House standard if your building's overheating, and that's a really important point to highlight. Some data just to throw at you. The average temperatures outside are here in the orange, and you can see as you get into the December there, they drop off well below 5 degrees C. But you can see that the indoor temperature in the on campus has been 21.9 for October, 21.7 for November, and 22.2 for December. One of the reasons for the higher temperature in December is because there's nobody in the building. So the building sort of is in an equilibrium when there's occupancy. The MVHR shuts on and off depending on that. So really good performance. And then indoor air quality is another plus of this. I think Andy Frew on the call here as well. There's been some great work done by the Northern Ireland Housing Executive on a publication there about maximising the benefits and realising the benefits of Passive House. And they were one of the contributors to this. And one of the big benefits to Passive House is the indoor air quality. And of course, in light of the pandemic, that's even more important. We have some data here to show you in terms of what the building is coming out at. Outside, unfortunately, the CO2 of all outdoor is just sitting at about 400 outside, and then that's part of the climate change issue. We didn't want to go across 400, but I think the world has just recently gone past 400. But the Earn Campus indoor data from it opened, you can see there month on month, it's sitting at less than 500 CO2. So that's almost the same outdoor, the same standard as outdoor air internally, which is great for us. Costs, some people might be want to know about this. Again, you're talking almost 30 million. That works out at about £3,500 per metre squared. Again, I did a wee bit of digging this morning just on that. In 2018, the average price per metre squared of a university building in London was 3,300. So again, for a world-class groundbreaking construction, it wasn't that we broke the bank either, and the building came in on time and on budget as well. For us in my department, with the R&D work we've done, this has been significant. We have seen a serious uptake in interest coming to us. We have turned over since 2015 and getting into Passive House over $1 million with sustainable construction R&D. And that is a really good outcome for us in the college. It also allowed us we were invited to COP26. It was really a proud moment for us in the college, and we were asked to sign an MOU to become part of this UN Centres for Excellence for High Performance Buildings. So we really feel we're punching above our weight in some respects, but we've also done some good stuff. We also have things to learn and a way to go, but we're in good company with respect to that designation that we got. And we're looking forward to, you know, again, the Northern Ireland community, the construction sector in Northern Ireland, you know, rolling out a series of events around that as well, with being that centre. Inside the college, it's been a catalyst for a number of things, in particular our One Planet Living initiative. So we put in a new sustainability strategy going forward. The college has a big ambition to be the first zero energy college by 2030. Again, we've a way to go on that. We may have been bitten off more than we can chew, but we have that aspiration and we're working towards it. One of the events I'm hoping to announce soon is a summer school, which will hopefully be in September later this year. So keep an eye out for that in the coming weeks. And we'll have other events, of course, as well. Again, just to conclude, for Northern Ireland, we feel this is an extremely significant building. It's the first passive house building in the UK. Right after us, just opening next week, or I think this week, is the new swimming pool in Exeter and Leisure Centre, built to the passive house premium standard as well. I can't remember who's the bigger building, but it might be about to knock us off. Which is really a lot happening in the UK in general with passive house. Again, it's allowing this all to percolate into the construction industry. And we're only one of a few where you can come and get training and all the rest. We have, off the back of this, and it's relevant for this topic matter, we really are now focusing our attention on retrofit. We see the opportunity, we see where it needs to go with respect to embodied carbon. And we have some funding secured to really roll out some initiatives around retrofitting, in particular, the EnerFit standard as well. So we're looking forward to again coming out with that. And again, I suppose the college new construction or the Erin campus is just an excellent example again of how renewable energy should be used. There is no point in putting the cart before the horse, as they say. If you're going renewable energy and technology, and everybody loves talking about all of these things, if you don't have the energy efficiency first to a really low level, the goose is cooked, because later on you're going to have to go back and retrofit, or you're going to need to add more costly technology and renewables. So this is really the secret sauce, I feel, you know. There's my email address. Everybody and anybody, please contact me. I don't mind. It's all good to talk. So yep, that's me, and hopefully that generates discussion.
Thank you very much indeed, Barry. I am very conscious of where we've got to time-wise. We have 7 minutes left, and Aoife wanted to say a few words about the way forward. Natalie has been doing an excellent job at answering the questions that have come forward in the Q&A piece, so please carry that on, Natalie, because it may be a very constrained Q&A piece because of the amount of content we've been trying to get through. But Aoife, do you want to say a piece around the next steps? You have to come off mute first.
I'm guessing we don't have time now to do the education part, the second presentation. Should we skip that and just go straight to the next steps?
Yes, I think so, please. I think just in conscious of the time.
Yeah, that's fine.
Because I think the bulk of the questions that have been asked have been answered by Natalie doing sterling work there.
Yeah. Can you see my screen?
Yes, but not yet as not in screen, full screen view yet. Not in presentation, but there we go, yes.
Yeah. So this is more, how do you say, a general sort of wish list. You know, and it does combine not just embodied carbon, it's also including thoughts around, you know, helping us shift towards net zero emission. But one of the first things I would say, at least, you know, from my own experience, is developing a really clear definition. And like I said, you know, from the work that we've been doing in the IEA, to have more of a framework so that we have transparency, but we have flexibility, you know, so that we can have a sort of a stepwise approach to achieving net zero. So it could be, you know, that even some buildings might want to try to achieve net zero energy first, then shift towards net zero emission, and maybe start to think about developing a sort of a stepwise, you know, like a, how to say, not moving targets, but, you know, like the ZEB ambition levels. So you would have these varying targets, let's say, that different buildings could aim for. And then, obviously, in terms of the calculation methodology, it would be really great to have a sort of a common and agreed approach to that. And a really key element is reliable source of data. And I know that one of the questions has come up about that. I don't know if you want me to mention that now or later, about sources
whenever
for
we can,
UK.
whenever we can in the next 3.5 minutes, Aoife, we must.
Yeah. So just to say that what the EPDs for the UK, I would recommend looking at my colleague Jane Anderson. She has Construction LCA. It's a website, and there you have it's like an EPD database that you can refer to. And within that website, you can also refer to the Irish Green Building Council, so that you could source EPDs that are more applicable to the Irish market. In addition, you have the Eco platform that I spoke about that is more sort of European based, and then you have the, well, obviously international EPD system. But within all of those, you have embedded EPD libraries. There's also the ICE carbon inventory from the University of Bath. That's a really good source as well for generic as well as specific data. I'm just going through my wish list. You know, I would say also, you know, just trying to coordinate all the different efforts. You know, there's a lot of momentum, which is really great. But maybe we need to sort of develop something similar to, you know, a comprehensive knowledge hub where we can sort of try to coordinate all the different initiatives, agree on definitions, agree on, you know, good sources for the data, calculation methodologies, and start to have one place where we could maybe start to coordinate for grant proposals or trying to find funding to develop the actual pilot projects. So I think I'll just leave it there for now, but I've just put at the end, you know, not reinventing the wheel. You know, there's a lot of research already done, like I said, in the ZEB and Zen Center. We also had the IEA Annex 57, where we looked at 88 case studies from around the world. You can look into that website, there's lots of publications. And of course, we have the current research in the Annex 72, which has case studies and definition work. So I think I'll just leave it there so we can hear from everybody else.
Thank you very much, Aoife, just giving us that flavour of what we need to do. Yes, we will be, Amy will be distributing the slides. There are one or two that just have to be looked at for confidential information, but they will come round soon, the various presentations. I'm not going to be able to throw it over to the floor. There was so much stuff. It's a quartz into the pint pot and everything. But I think we've passed a lot of information over. We need to think then about how we regroup on what we do with this. Whether that be government, academia, wherever it may be. But hopefully that and seeing the slides will give people much to chew on over the coming days and weeks. So I want to say thank you very much to Amy in particular, who's made this happen. Robert on the polar bear on his ice floe there said yes, let's do this, but then was unavailable. So Amy has picked up the baton admirably. I want to say thank you to Aoife and to Barry for their different presentations, and Aoife for bringing along a fan club with her as well, which is always excellent. And I want to say thank you very much indeed and a very large room there as well, much bigger than any of our other rooms. And I want to say thank you very much to everybody for attending and for the questions you put up in the chat, and to Natalie for the oracle answering them all as we've gone along. So we will come back to this. It's a really important topic, but thank you everybody for the steps we've taken on it this afternoon, and go well and see you soon.
Okay.
Thank you so much.
Thank you, everybody.
Thank you.
All the best. Thank you. Bye-bye.
Take care.
I'll just